All right, welcome everybody. Excited to see you all in the last week of classes out here. We have two wonderful speakers coming in, both people I've known a very long time. When I landed at Berkeley, I landed in the Rad Lab, which Dave was running. And of course, we all know Dave Patterson, Turing Award winner, among many, many, many other accolades. And then I came in with Andy, who was also in the Rad Lab, and stuck around in there. Started some notable organizations such as Databricks and Perplexity. And they're here to talk about some of their new initiatives going forward. And I'll hand it off to Andy.
All right, thank you. How many PhD students in here? Okay, maybe like a quarter. Undergrad? Okay, faculty? All right, I think that's the plurality, the faculty. That's great, pretty good mix. About third, it looked like, but a little bit more faculty. So that's wonderful. Thanks for coming to the talk. We'll kick it off by watching this.
P6 chip. Triple the speed of the Pentium.
Yeah, it's not just the chip, it has a PCI bus. But you knew that.
Indeed. RISC architecture is going to change everything.
Yeah, RISC is good.
RISC is good. Okay, so 1/3 of you do not get this. And maybe you understand RISC is good. We are all carrying RISC processors in our pockets right now. There are over 200 billion of them on the planet. And even in 1995, when this movie came out, Angelina Jolie's character knew that it was going to be a big deal. Does anybody know what movie this is? Raise your hand if you know what movie it is. Okay, at least 1/3 of the people in this room probably will know. Since it came out in 1995, long before most of you were born. Somebody say, what movie is this? Hackers, all right, and that's Angelina Jolie in a younger form. See if I can skip. So the reason that we started with this video is threefold. One, even in 1995, Angelina Jolie knew that RISC was a big deal, and she was right. And this was in the news recently. So reason number two is that this was in the news in Wired 3 weeks ago, in which they featured the long-term impacts of the RISC architecture, and that's one of the highlights of Dave's long career of having impact out of his research. And we're going to talk a lot about the lessons he has learned in the 2.5 talks that we're going to smash into this one talk right now. The first of those 2.5 talks is Dave sharing the lessons he's learned building RISC, RAID, and labs that have produced other world-changing artifacts like Apache Spark. And then the second of the 2.5 talks is a project that was inspired by the legacy of impact Dave had in his 40-year career that Dave and I kicked off a year ago, culminating in a paper. And the second mini talk is going to be the results of that paper, or the lessons we learned publishing a paper about the impact that AI will have on society and the way that researchers can shape that impact with our research agenda. And then the last half talk is introducing a preview of a grant program that we're going to announce publicly in 3 weeks, which will fund research to come out of the second part of the talk, out of the paper and the moonshots that we put forward in it. So that's a little preview of what we're all going to talk about. The third reason that we start with this video is that it had an impact on me during my formative years in middle school when I watched it and realized that I wanted the lifestyle that was portrayed as computer hacker culture in the movie, which is more or less how computer science has gone for me. And the impact that Dave Patterson and the style of research, which echoes a lot with the style of research many faculty here at UW do, has permeated my career in its various facets, including the research that I did at Berkeley as a PhD student, the open source projects that I made major contributions or co-created, the companies that I've started, the class that I teach at Berkeley about how to have impact in the form of startups if you're a PhD student at a top university. And most recently, this organization Dave and I are creating together with many others that aims to provide researchers with the right resources at the right time, whether that be a no strings attached form of grant writing, other types of resources like engineering capability or communication support or community support, or writing a check into a startup after a researcher has created it. So that all in retrospect, that at each of those stages in my career, I've been deeply influenced by this model that I learned from Dave in the Rad Lab, concurrent to Curtis, had me thinking, has me a believer, essentially, that while Berkeley has produced some world and humanity-changing innovation, things like RAID and Apache Spark and BSD and TCP/IP, I still think that if you zoom out one order of derivative, the research approach itself is the most valuable export that Berkeley has to offer the world, and the lessons that Dave digested in this paper that he wrote called How to Build a Bad Research Center about a decade ago, digests those into these 9 commandments that Dave will now share with us. So that's the next part of this talk, Dave Patterson, to share 9 commandments for how to build a bad research lab.
Okay, I got to lap my. Yeah. So this is the third of my bad advice talks. When I started at Berkeley, we wanted to teach graduate students how to give talks, so we thought it'd be fun to teach them how to give a bad talk, so that was the title. And a couple of years after that, to try and capture advice I give how to have a bad career, and this one is how to have a bad research lab or center. And the way these talks go, you give commandments how to do it badly, and then if you don't want to do badly, then I talk about that afterwards. So the commandments for a bad lab is thou shalt honor thy paper publishers. The coin of the realm of academia is papers, so you want to write, and cite. Thou shalt not mix disciplines. It takes more time to talk to people in other disciplines, which means you can't spend as much time writing, so that hurts your productivity. It hurts commandment 1. Thou shalt expand the labs. To be able to write papers, you need research funding. And the more people you have involved in your effort all over the country, the more likely you'll get good reviews, because you'll know almost everybody writing the reviews, so the more, the merrier there. Thou shalt not talk to strangers. You're writing all these papers, they can just read your papers. Why waste your time talking to them? And then thou shalt not disturb thy neighbors. So, you want everybody in your lab writing as many papers as possible. You don't want them talking, so the model is good fences make good researchers. Thou shalt not build graven prototypes. Prototypes, if all they probably do is give ammunition to your enemy, if it's not working, they'll use that against you. And if you spend your time doing prototypes, you're not writing papers, go back to commandment 1. Thou shalt make decisions as a consensus of equals. We live in a democracy. It should be very even distribution. And the paragon of virtue of decision making is the U.S. Congress. That's our model. Thou shalt not limit the duration of the lab. If you're trying to get students, you're trying to get funding, you have to tell them, I'm just going to work on this project. It's so important, I'm going to work on this for the rest of my life. And that shows that you mean it. And don't start the delay of research. This is the one Andy wanted me to add, the 9th commandment, is that just jump in there and get going. When I joined Berkeley, I spent like a week or 2 deciding what to do, and I started working on the thing I thought everybody was working on, and so I could get in there immediately and start writing papers. And I guarantee if you follow these 9 commandments, you will have a bad lab. You might even be able to leave a couple of out and still have a bad lab. Okay, if you don't want to do that, let's go over the commandments. Honor the paper publishers. No, honor positive impact. When I first joined Berkeley, nearly 50 years ago, I got there when you're assistant professor, you don't know how the place works. What does Berkeley value? Is it okay for me to write papers with senior faculty? Do I have to have sole authored papers, first one? And they said Berkeley values impact. And it says, not the number of papers, nope, not sole authorship, nope, not research dollars, impact. So I loved that liberating advice and set off on that path. So the reason we count papers is if it's really high impact, it's probably got papers associated with it that probably have citation house, but it's not this direct measure of impact that people think it is. It's just easy to measure, that's why it's popular. So for example, the LLVM compiler out of the University of Illinois, it's the standard compiler technology today. It's taken over from GCC. That was rejected by the main conference in its field, PLDI. Similarly, World Wide Web, the thing that everybody uses all the time, the first paper, and it was rejected by its home conference, Hypertext. It's some kind of, if it's a high impact research, it's not going to be universally accepted. There's going to be questions about it. It's going to go into conventional wisdom. So for example, I'll show you some of the high impact labs, and the highest impact paper, as I look back from the Berkeley RISC project, has less than 1,000 citations, but the paper that Andy and I worked on about cloud computing has 15,000. And the risk thing had very high. The Rad Lab didn't have 15 times the impact that the risk project had. Also, the best paper awards aren't predictors of high impact. For example, an award I really like are test of time awards that are 10 or 15 years later, where we look back at the papers that appeared and which ones really mattered. Very rarely are the best paper awards at those conferences also the high impact test of time awards. And that's because the best paper awards go to the papers that all the program committee likes a lot. And those are rarely breakthrough papers. It's more likely that it'll be unconventional. People won't agree that this is a good idea. And some people like it, some people hate it, and those don't get the best paper awards. But they can get the test of time awards. So as I look back at my projects, what was the leading indicator sign that we were onto something? It was when non-researchers started using our ideas and what they were trying to get done. When people in the real world started using it, that was a really positive sign. Okay, so impact, not papers. Thou shalt not mix disciplines. No, multidisciplinary teams have much greater opportunity. I've believed that for decades. I think I've been giving the same advice actually for decades. I wasn't like, I got the Turing Award and let me re-engineer all my advice. It's been pretty consistent. So I've always thought that, if you compete with industry, industry has so many more resources, it's hard to succeed. And it's very hard for industry to do multidisciplinary. They tend to have big organization, each discipline. It's hard to throw them together. At a university, you have individual world-class experts you can put together in a room and make it do it. So it seemed like the best chances was multidisciplinary to have impact. I think I just said that. Also, if you're going to go tackle something a little different, it's kind of comfort. Strength in numbers helps. You have you and several of your friends say, we're going to do something none of us have ever done before. There's a little safety there rather than you're going to go work on something completely different. In one of the projects, we started working on cancer genomics. That was a completely different field. It would have been very scary to do it by myself, but with a bunch of friends, it felt not as difficult a thing to try. It does take longer for multidisciplinary work to talk to people in other fields because they have different cultures, different jargon, different values. It takes longer to underappreciate that, but if you want to have impact, that's worth that extra cost. So for the projects that I did, a pretty good number was 3 to 5 principal investigators. If each of them was in a different field, then there was no question who was the expert, and that was how it worked best. Thou shalt expand the labs. No, kind of my model of faculty is that they'll promise almost anything to get the money. And even if they were to put one investigator in 15 different universities, just as long as they get the money, and it'd be a lot of money, but everybody get like one graduate student and hardly anything get done, they don't think about how hard it will be to make the lab successful when they're trying to get the money, rather just make sure they get the money. So especially if it's multidisciplinary, the farther the PIs are apart, the harder it is to collaborate. And if you have a huge number, it's very hard to be successful. And there's an actual NSF study that said by Sarah Kiesler at Carnegie Mellon and her student, that when they looked at multi-university projects, they tended to be less successful. But if it was multidisciplinary, especially if it was in one place, it excelled. So there's even data to back up my kind of biases there. Thou shalt not talk to strangers. No, and I would say if you had to pick a single feature that was critical to the success of these labs, it was this retreat model. We would go off twice a year for 3 days, to some nice place, so everybody would be there. They couldn't sneak out. We would go to Lake Tahoe. This is one of the first projects did it. It's almost 40 years ago. Susan Eggers, who used to be a faculty member here, Mark Hill, who used to be a faculty member there. I've been around long enough that former students have retired, which that's some significant mark. But they did both Susan and Mark won the highest award in computer architecture that Mark Liga won, so they had very successful careers. The key piece in this is in talking to strangers, is feedback at the end. For the last couple of hours, we get praise and constructive criticism from people we respect, from Microsoft, from companies in the Bay Area, bringing them together, feedback. And the amount of feedback you get twice a year for 3 days is tremendously higher than what you get from the reviews on papers. So it was really important. It also gives us deadlines. It was team spirit. We would go skiing together in the winter, go rafting in the summer. And it gave the students involved a chance to present their ideas twice a year to an interested party. And it's really vital for what was going on. So that was 40 years ago. Here's about 20 years ago, and on those slides there's Matej Zaharia, who I'll talk about, and there's Andy Konwinski, and this is the joke I do every time. There he is with the grad student goatee beard, and there he is with his PhD beard. And people laugh, that's why I keep it. And there's the faculty involved, and it's a, what?
Where's Curtis?
Oh, that's a great idea.
He was probably like in his hotel room.
I'm social enough. I remember having a photo.
I don't see him.
It's a little dark.
You weren't there.
Oh, well.
Proof is in the photo. Maybe Curtis actually never was in the Rad Lab.
He just wanted to take the glory of being a member.
I took the trip. You guys take us to a ski place, I'd go.
Yeah, okay. This was, the retreats were just vital for this. And part of why did we go offsite? Because if we did it on campus, people would just drop in for their piece of it. But we needed to bond them all together. That's what we off. And it was fun too. Thou shalt not disturb thy neighbors. Kind of halfway through this, what happened was the internet got as fast at home as it was on campus, and the computers were the same. You'd use high-end PCs at home, like on campus they were high-end PCs, and you just buy a copy yourself. So suddenly, you didn't have to go in to get your work done. And so people started staying home, and it came like kind of this desert. Nobody's around. So I didn't, whether that's a good idea in some circumstances, it didn't seem good for research, so we wanted to try and fix it. So the idea was we remodeled the space, put the faculty, students, staff all together there. And to get people to come in, they have to be able to concentrate, but we needed this spontaneous communication, so we'd have these meeting rooms, and at the time we novelly got rid of landlines, relying on cell phones, which everybody does today, but obviously landline phones were terrible for concentration. And the meetings rooms are fantastic, wall-to-ceiling whiteboards, and you could yell and argue and write on the boards, and it was a very exciting place to be. And then we made it homey with food and drinks that are available for free there. And it accelerated research. People came in more. The faculty came in more. The students came in more. We could, you could grab people and go to the meeting room rather than schedule on their calendars to get together. And the stunning thing was, to me, the 0 to 60 time. I was used to graduate students, like the first year and a half for them, trying to feeling their way around, what's going on, how they get involved in the project. And so 2 students in that first lab wrote a paper, got it published, and was invited to give a talk at Carnegie Mellon University because they were so interested in their results. And those 2 students were Andy Konwinski and Matej Zaharia. Now, as we look back now, we think, well, yeah, sure, you had Andy Konwinski and Matej Zaharia. Of course they did well. But was it Andy and Konwinski and Matej the reason, or was it the lab that let them nurture, and take off? So I think the lab played a big role. And then after we experienced this thing that we kind of stumbled into, we read papers to see if this was a good idea. And there's, oh yeah, it's well established that you could put 50 people in a room across, and it makes them very productive, spontaneous meetings, all that stuff, well understood. You can't like suddenly have something 1,000 feet across with 500 people and make them all productive. But for 50-ish people, that's well understood piece of technology. So making sure that neighbors talk to each other is important. The one downside in retrospect was that we could do it for the first time and the faculty would come and join depending on the project, but after that there's kind of a stickiness to the faculty being in the space, and we couldn't easily do the swapping afterwards. So If you're going to try and do the optimized space, you won't need to have a way that the faculty can come in and come out so that you could put the faculty on that matches the topic that you're attacking. The sixth thing is building the graven prototypes. That one's RAID the first with our fancy labeling on it. But this lab-wide prototype that demonstrates the lab's vision is really vital. It gets the people from these different backgrounds not just talking about it, but working together, learning from each other, and trying to get it to work. And the good thing that happened is open source software became more popular over time. And that's tremendous for universities. You get more help to help people building it, and it helps with the technology transfer because you have outside people doing it. The downside of the prototype is trying to convince the students involved that working for the common good is their part of the common good, and it's good for them as well. And it's hard in advance. They have to take it on an article of faith. But once they see other people in the lab using their ideas as part of their work, then they can get on board, and it's clear what the benefits are. Making decisions, the consensus of equals, no, Congress is not a great model. You need to find a leader who will spend the time to pull everything together, who will work on the team spirit, and that the other PIs can just have faith that that person will do the right thing. I probably led about half the labs, but I was thrilled when somebody else led the lab. We just rely on them to do it and make sure everybody pulls together. What you're looking for is somebody the goal is to make the team win versus being the most famous coach. Limit the duration of the lab. This is probably the part that's the hardest for other faculty to follow. My career is based on these sequence of 5-year labs. So where did that come from? Well, I was told they value high impact, and they don't care people, and most research doesn't work. So the things that they count, like when they introduced me today, they counted, well, he worked on risk. They didn't say, oh, remember Dave worked on the X tree and that never went anywhere, and IRAM project was a dud. They don't talk about the things that work. They only talk about things that work. Well, if they only talk about the home runs, then let's just swing for home runs and not worry about it if we don't make it. And so you want to have a lot of at-bats. If you do 20-year projects, you don't get very many at-bats. And then in our field, things change so fast, it's really hard to know what the world's going to look like in 20 years. Those of us who have been in the field for a while, like every 3 years, we say, I can't believe how fast things are changing. We keep saying that same sentence every couple of years. And who in their right mind would predict what our world's going to look like in 2040? 15 years from now, God knows what it's going to be. So if it's so hard to predict, then a shorter-term project makes even more sense. And then finally, most research doesn't work. So if most research doesn't work, you need some mechanism to stop what you're working on. After 5 years, it's very hard to tell whether this is going to take off or not. But if you have an end of project party after 5 years, you're kind of forced to move on to the next thing. So there's this potential of a huge opportunity cost of working on something that's not going to work out. This way, you're forced to move on to the next one. The downsides are all the students have heard about the old lab. They want to work on that one. The funders have heard about it. But what's the goal here? Is the goal to make it easier to get money and students, or is to have high impact, right? And I think the 5-year labs are a big piece of that. The last one, not delay the start of the research. It's unlike what I did when I joined Berkeley, you should think before you act. Even if you're not doing 5-year projects, spend the time to think about it. I think we spent a couple of weeks thinking about what we do when I joined Berkeley. And later, for some of the projects, we would spend a whole year trying to figure out what we should do. And especially if you're going to do more frequent labs, this process of how do you pick the next lab, you need to think about it. So we would think about technology trends, see which faculty are interested in these opportunities, talk to people from outside, get feedback, and that's how we determine the next project we can do. So depending how you count, somewhere between 10 and 12 projects over my career, I would say 5 of them are kind of home run labs. Andy talked about risk. The R in ARM is from risk. There's like 250 billion risk ARM processors have been shipped. RAID was a reliable storage system. Used lots of small disks that could be more cost efficient, faster, and more reliable than a few large disks. That was RAID. RAID turns out the write performance is limited. That inspired Mendel Rosenblum and John Osterhout to do the log structured file system. At the same time, Postgres was an object relational database that Mike Stonebreaker was doing, and that's now a very popular open source system. A network of workstations was, let's build a supercomputer out of off-the-shelf workstations with switched local area networks. It was actually, we had the first cluster, the top 500 supercomputers. We also set, Jim Gray had this database search thing. We set records with that. But the killer app turned out to be, come from a new faculty member, Eric Brewer, and his grad student, Paul Gauthier, who said, I think this technology would be good for internet services, like for search engines. At the time, Alta Vista, which ran on big shared memory multiprocessors, was the go-to search engine. They showed that theirs, which they called Inktomi, that was running on the Berkeley campus, was actually the most popular search engine for a while. And then they started a company that used those ideas. Once Google debuted, they took over, but they used the same cluster technology to do that. The RAD lab, which Curtis and Andy were on, that was using systems plus machine learning to make it easier to run data centers and create apps. In that open space, Matej Zaharia was sitting next to machine learning students who were trying to use MapReduce on big data to do machine learning algorithms. And that wasn't working. It was really hard. And so out of their frustration, Matej invented this data analytics system, Spark. And that was at the legacy of that lab. That a couple years later, Andy, Matej, Jan Soik, and some others founded Databricks, which now employs 7,000 people. The next lab was the PAR lab, which was attacking the problems of multiprocessor hardware software, about to switch to multi-core. As part of that, there was a couple of things that came out of it. But the big thing was RISC-V, this idea of an open architecture. We did a modern RISC architecture, intending it for other academics. They weren't so excited, but industry really wanted to have an architecture that anyone could use without paying fees and without any restrictions, and that took off. And today there's conferences on three continents, 400 organizations involved, 2 billion chips shipped, projections for 30 billion in a few years, so another home run. So that's kind of the technology story. What about the people involved? It's tremendous for grad student education. Mark Weiser, computer visionary, talked about the projects on the SPUR project in the 1980s. He said, this is the best group of grad students I've ever seen, and this is almost word for word what Burton Smith said 20 years later about the students in the PAR lab. Best group of grad students I've ever seen. I think it was, all our places get great people applying, but this kind of lab model let them excel, learn from each other and flourish. And it was good for the faculty as well. There's about 30 faculty worked on it. 13 of them were subsequently named to the National Academy of Engineering, which is a very high honor, and that's about 3/4 of the people in computer science at Berkeley. So the summary of this thing is aiming for impact versus papers. If you get this feedback from retreats, that increases the chances of success. This open source is a huge benefit for universities that can help with technology transfer. You need to find somebody willing to lead it to help it be successful. If you can get the good space, it accelerates progress. Make sure you take the time to pick the problem, and then aiming for these multidisciplinary labs with sunset clauses works. And when I put this talk together, it makes you want to think back and reflect on it. Like this advice to switch every 5 years. Suppose I hadn't done that. Suppose I just started working on X-tree and worked on that for my whole career. Well, how things would turn out differently.
That's a good thought experiment to run. Let's ask ChatGPT. How would the world be different if Dave Patterson had never moved on from his first project, X-tree, to do risk? Slower evolution of CPU architectures. CISC might have won. We'd be carrying massive laptops in our pockets instead of cell phones. Weaker foundations for mobile. Maybe IoT wouldn't have happened. Computer science education would be different. Conceptual clarity. Okay. Oh, this would have been horrible. Oh, all right.
There can't be any university that teaches x86 architecture anymore, is there?
All of academia industry might have shifted. All right, open hardware, Patterson's career would have had less impact. AI chips have been more constrained, proprietary, and less power efficient. No, we don't need a speculative timeline. Alternative. We just got an alternative history. Great. Sometimes, this is a pretty good one. Sometimes ChatGPT doesn't think so much of Dave. I have to like be asking very complimentary questions about him to prime it before we do the talk. But my backup lately has been to go to Perplexity. It's a little more evidence-based and says nicer things. Okay, so let's see, I use this. That's the 9 commandments now. And as I said, I went through the rad lab, Curtis went through lab, and these left a long-lasting impression on me that I've seen show up throughout my career. About a year ago, I had the idea, after going off from research and spending time in industry building companies and then doing an AI company, that we could team up again. And so I reapproached Dave with this pitch to make more of these labs happen in the world. I can share a little bit about why I think this is a particularly relevant time for these labs and a focus on impact to happen. So Dave and I got beers about a couple blocks from his house on off of Solano Ave in Berkeley, or north of Berkeley, and we came up with this plan that was inspired by the paper that Dave mentioned. He and I were 2 of the co-authors on years before, in which we identified some opportunity to write a vision paper around the current trend at the time, which was public cloud computing. And in that paper, we called the trend based on some economic argument. We said public cloud was going to beat out on-prem eventually, even though at the time it hadn't happened yet, because of some of these economic things like provisioning for peak just doesn't make sense. And some of the constraints on public cloud would be taken care of by legal agreements, et cetera, et cetera. It turns out that when we started Databricks, we actually made a bet on public cloud that was not popular with our investors, and we held the line. We said no to a lot of customers that wanted us to support on-prem. Just 2-3 years after Cloudera had named themselves Cloudera and then turned tail and gone to on-prem, and were not in the cloud. And we said, no, we're going to hold the line and do what Cloudera did in the first place, but stick to cloud this time. 2 years ago was too early. Now is the right time. Informed in large part because of this paper we've written. And we were right. We ended up being on the right side of history for that particular technology paradigm. When I pitched Dave on the idea for this new thing, it wasn't an opportunity to say generative AI is going to change everything. That was already pretty clear to everybody. So that was not like falsifiable particularly. So the difference in this proposal was that instead of calling the trend this time, we were going to point out things that the implications of the trend would have on society at large, which I believe are very existential, and then we would fund labs to focus on those areas of research so that researchers, according to this vision paper, might help dampen the downsides or nudge the upsides of the impact of AI on society. Dave said yes to this proposal, and so we set out to recruit several co-authors and write this paper about the impact of AI on society, and that's what Dave's going to tell you in part 2 of this talk.
Okay. All right. So we're up to part 2. So what we had 4 assumptions going into this one. This was a more ambitious project than before. But first of all, even though AI has been around forever, the practical AI is just starting to work, and research could still influence it. We could enhance the upsides or reduce the downsides. And that there were people out there that wanted to hear this story about its upsides as well as its downsides. But it's more ambitious. It's not just people in our field, AI practitioners, but also policymakers and possibly even the public. And that we typically had just done it locally at Berkeley, but we were going to need to be multi-institutional. We could get people to volunteer to help us with things. And then we would talk to experts to complement our expertise outside of our field, and that, that these experts, dozens of experts, would be willing to talk to us. The topics we picked were employment, education, healthcare, information, media, governments, and science. And that we would volunteer to actually write a coherent paper that would actually make some kind of difference in our society, which today is just this snap judgment society where people will hear a little bit about it and either fully embrace it or completely write you off. So it took us 9 months to write the paper. It's about a 30-page archive paper. To try and get interest in it, we were able to get a short piece in The Economist to try and let people know about it. And then to reach out to the public, we've done a comic book as well. It's our 2 cents, that's the joke there. Unfortunately, the comic book delivery person didn't deliver the comic book, so if you're interested, you'll have to contact us later. So this is the team. There's senior computer science like me and John Hennessy. There's rising stars like Finale Doshi Velez, Emma Pearson, who used to be at Cornell, now at Berkeley, and then Sanmi Konyenko, who's at Stanford. There's entrepreneurs like Andy and Pelonomi Mola, and then Jeff Dean, your alumnus, senior guy, both in computer science and machine learning, and Tino Cuellar, the former California State Justice, that brings in more of the policy issues. We were able to interview John Jumper 1 month before he got the Nobel Prize for his work on protein folding, former President Barack Obama on governance, former National Security Advisor Susan Rice about security issues, and former Google CEO Eric Schmidt on a host of issues, and 20 more people kind of in that range. These are the papers that we talked about, but if you can remember shapingai.com, you can find links to all of those things. So as part of, after thinking about it, talking about it, and interviewing a lot of people, we came up with 4 guidelines that we think generally apply. The first is that humans and I, working as a team, do more than working all by themselves. And so if we can get the AI community to focus on human productivity gains, that's where you get more positive societal benefits than if we focus on human replacement. It's going to make people more employable, not lose their jobs. And then people are around, so if AI veers off course, to try and correct what's going on. And then rather than trying to skip ahead for the community to really phenomenal scientific AI innovations, let's just start by removing the drudgery of people's current tasks so that we can win them over to believe that AI is going to be beneficial. So if it's K through 12 teachers, maybe it'd help with grading, maybe it'd help with communicating with parents. If it's healthcare workers, maybe it's the insurance documentation or things like that. Teachers want to work with students. That's what they were drawn to the field. Healthcare workers want to help patients. That's why they're there. So help them be more productive in what they do. And this productivity focus, we think the bottom line is it helps AI succeed and people succeed. Now, technology has long had this giant impact on employment. Almost 2/3 of us today have jobs whose titles did not exist one lifetime ago in 1940. I collected data from the decannial census data, and in 1970 we had more typists and telephone operators than we had lawyers and programmers, and then 50 years later, it's that those roles are reversed. And from talking to labor economists, a healthy society, a healthy economy relies on improving programmer productivity. 2/3 of us on this planet live in nations whose populations are declining. 2/3 of us. So what are we going to do? So for people like Ed and I, we're going to be able to retire. But the number of 50-year-olds 50 years from now have already been born. So if we don't improve human productivity, we're going to be in a really tough position. And we're already facing labor shortages today. And so AI is a technology that can improve productivity and can help with this shortage of people to do the work. So if we're going to help employment, let's aim this powerful tool at jobs that create more, at fields that create more jobs. So for example, despite tremendous gains in jet airline travel and tremendous gains in computing over the last 50 years, there's 8 times more commercial airline pilots, 11 times more programmers, according to US Census data. So what is this about? So when economists talk about a good that if you drop its costs, its volume goes up much more than the drop in cost, they call that elastic. So the idea is let's aim, well, passenger travel and programming were examples of improving productivity in elastic fields that actually increase it. It's more productive, but it made it even better, so we got more jobs out of it. In contrast, the fields that aren't that way are inelastic, because just because you make a lot more food doesn't mean people will eat a lot more food, so it'll reduce the number of people doing it. So amazingly enough, in 1940, 1 in 5 Americans who were worked on farms in agriculture, and now it's less than 2%. Okay, so let's aim this powerful tool at fields where it's going to create more jobs. The other one is geography matters. We're worried in high-income nations that people go to school for a long time, they get jobs, they get replaced by AI, and that's worrisome. But in low-income nations and middle-income nations, there's just not enough of this skill to go around. So Honduras, a little bit south of Mexico, has 1/7 the number of doctors per capita as the US. So they don't have the healthcare expertise just isn't available. Similarly, for other skills. So there's an argument that AI can supply the missing expertise that's needed to grow these economies and improve the healthcare. The last one is to just use the right tools to measure it. We can't be sure that AI is reaching potential if we can't measure the gains that are being made. So in high-stake domains like education, maybe healthcare, we use A/B testing and randomized control trials. Other times we can just get away with market surveys, like probably for programming tests. But once the tools are deployed, we got to keep being able to measure it to make sure they're doing what we want, they're not doing something that we don't want. And then after we've deployed it, we need to upgrade it in the field. We need to make sure it's still doing the right thing. So we got to have the right tools to do it. So what could happen, or how could we influence these people guiding these guidelines? And so we thought what we would do as part of the paper is give concrete targets. So let's apply AI at this topic in healthcare or this topic in education. And if you hit that target, then it would help AI advance and help society. And so part of the model would be when there's research to do it, great. And if not, we would create research labs like Andy talked about to help people reach those milestones. As part of, to inspire people to hit the milestones, we're doing inducement prizes. So inducement prizes, of which the X Prize is the most famous, is to offer $1 million or more for people who hit the prize. So that would be part of the model going forward. There's a government version of this, which are called advanced market commitments, which you can think of kind of inducement purchase orders, where they create a purchase order for products that don't exist. This is how NASA deals with private rocket ship companies, and this is how the US developed the COVID vaccine. It created a purchase order for a vaccine that exists to give a market for companies to shoot for. And when Andy came up with this idea, we thought, let's bet on philanthropy to do this rather than ask for government funding. And that was completely independent of the change of administration. That was our goal. So what could happen if we do all this? Well, a recent National Academies report talked about potentially AI could double the growth rate of the gross domestic product in the United States. If that were true, what's the consequences? Reduce poverty, improve healthcare, a better environmental impact, strengthen our national defense, and reduce the budget deficit. If it could do that kind of doubling. The middle class in many high-income nations have been hollowed out through a combination of globalization and computerization. One of the labor economists said it could potentially rebuild a middle class in these countries. And then finally, what I talked about in the middle and low-income countries, this lack of expertise, supplying that expertise could really accelerate that. So I think our bottom line there is that when we see these conversations, people can either forget about the risk or forget about the gains. And so it's as big a mistake to ignore the potential gains of AI as it is to ignore the risks. Finally, towards the end, we thought, well, maybe we should, like President Kennedy in the 60s, propose a moonshot, get to the moon by the end of the decade. But it was actually pretty difficult. It's kind of, we didn't reach agreement. Like, which one should we shoot for? Improve healthcare, accelerate science, get us a functional civic discourse, or help the work skills, places that are displaced because they're aimed at inelastic jobs. And what we realized was we didn't have to pick one moon. If we create the right blueprint, we can use AI to launch 1,000 moonshots. And with that, the question was, who could fund it?
And this brings us back to the original conversation Dave and I had. And so we are building a nonprofit called Laude Institute to fund it. And the funding that Laude Institute provides comes in turn from folks like myself, who are computer scientists who have done well by research turning into product. And so I will bootstrap the first few labs and set the way with motivation for others in technology that have done well from startups out of research to also do the same.
So this is the part of the talk where I marvel that, and thank God, that Andy just doesn't want to have a yacht the size of a football field. Okay, that's some billionaires. Say, God, can I have the world's biggest yacht? No, Andy says, I think I'd like to fund research labs. So I think a round of applause for his. Yeah.
But it won't work if only I do it. So if you have billionaire friends, feel free to introduce them to me, and I can ask them for money. And there's me thinking about giving away lots of money. Okay, so Laude Institute is an institute for and by top researchers, which means that we will fundraise from folks who are researchers themselves and fund the researchers in turn. And the goal is to take this state that humanity finds itself in and moving forward faster with AI progress, much of which is coming from the university system, and ensure that all of us benefit from it, not just the vanguard of humanity, not widening the gap between the haves and have-nots, but moving all of humanity forward. And the way that Laude Institute will do this is, as you'll see in a second with the grant program that we're going to announce in a few weeks, we give resources to researchers at the right time. And those resources might be events that we organize, including workshops that we'll do, for example, at NeurIPS, and PhD clubs that we help organize for students who are interested in impact through open source or startups, such as the Agent Club that is for PhD students here at UW, Allen grad entrepreneurs, which Curtis can tell you more about, or Joe, who's right there. Stand up, Joe. That's Joe. He's the president of Agent, and it's a club where PhD students in computer science interested in finding others who want to be co-founders or who want to learn about startups can go and be resourced. And so Laude writes checks to PhD clubs like this. There's one at Berkeley. We're starting one at Stanford. There's one at Wisconsin now, and here at UW. And we'll also organize a summit for all of you to come together, probably in the Bay Area, and meet each other and share notes. Of the founders of the original Berkeley one, 3 of the 6 founders became Databricks founders. So there's a pretty good legacy, and probably close to a dozen other companies have come out of it in the 12 years since we co-founded it, including Curtis's company. And then finally, we have communication specialists that help researchers get their message to the world, and that includes finding users, but more importantly, capturing the world's attention with relationships with journalists and a messaging plan from the beginning of the research project. So that's Laude. And the Moonshot Grant Program will be one of the 2 flagship grant programs that we announce on June 18th when we come out of stealth. And the shape of this program that now implements the research that we did in the paper is we will fund 8 seed grants at $250,000 each. The people who win these seed grants, so there'll be an application form to apply to and win the seed grant. The application will open next month. The deadline for the seed grant application will be this fall. I think just before Thanksgiving is what we were talking about. And if you win the seed grant, you will have 6 months funded for $250,000 to provide these 4 things: a vision paper that fleshes out the moon that you're aiming at, a benchmark that proves that you can think about how to measure progress towards this moonshot. It doesn't have to be the end game of your lab. You don't have to identify a benchmark that you, with high certainty, just for sure determines whether you're successful or not. That's a very hard problem, but we do want metrics-driven research. An open source proof of concept doesn't, again, have to be a full stack that implements your whole lab. You'll have the 5 years to do that, but it has to demonstrate that you know how to write code and that you know how to use Git. Not all researchers do. Then finally, a proposal for a 3 to 5 year lab that the Laude Institute, if you win that after this sort of seed stage, would fund to the tune of $10 to $20+ million. And yeah, we want all of you to apply. The actual target, so you have to pick a moon, and moons float around planets. So we are outlaying 4 focus areas that you might choose your moon around any one of these 4 planets. A functional civic discourse in the next 5 years. A century of scientific progress in a single decade. That's from Dario Amade's blog post about a similar topic. Broad AI for healthcare practitioners, or I like to say, reinvent the US healthcare system. Workforce reskilling to counter AI displacement. And so you saw some of these tie into the themes that Dave highlighted from the paper, and you can learn a lot more about the focus areas by reading the paper, as Dave talked about at shapingai.com. And we hope you all will apply, and if you have questions, we're happy to take them. So that's the end of our 2.5 talks.
So I'm European, and this might be a bit of an unpopular question in the US, but I was wondering, you talked about human AI collaboration really increasing productivity, and I believe that's possible. But I was wondering, what would we have to put in place to have this result in a, let's say, 4-day work week, rather than just working more, right?
Yeah, one of the guys I play soccer with, when I told him I was working on this, is, yeah, let's go to the 4-day work week. The history was, in our country, it used to be a 6-day work week. That was the norm. And then after the Depression, we solidified it to a 40-hour work week. So there's people who are arguing for that, and they're showing benefits of a 4-day work week. But it's pretty hard for us to control the worker productivity thing. If Americans are kind of the hardworking people who don't take vacations, so I just think with the thing I think we want to communicate, which I think some AI practitioners had not thought about, is that it's a little bit easier to do research or replace jobs. You don't have to do human subject experiments and stuff. It's kind of harder to work with people, show productivity, but it has this huge societal impact. Right? Is if you're replacing jobs, there's going to be people in your family that's going to lose jobs. If you enhance what they can do, this can improve it. So that's the focus. So, but can we channel it so that people will work less and do more? That's I think going to be hard for us to do. You have thoughts on this?
No.
Okay.
Not well thought out ones.
That would be great, though, if that was the outcome. Somebody?
Thanks for a great talk. You discussed this model of organizing 5-year labs around a moonshot, a challenge, a problem. I wonder how people transition into that, because many groups have 5, 10, 15, 20-year histories of faculty and students who are close-knit around a research area. And if you refactor that to have sort of one expert per discipline or topic, you're sort of going to dismantle that existing thing or pull people away from it. So do you try to do both? Do you switch to a model where everybody's always organized around these 5-year things? How do you transition to this model? I think that there's a lot of existing inertia of close-knit groups, and I don't quite know how to move between one and the other.
Well, like I said, I wrote this paper a dozen years ago, and as far as I could tell, people ignored it. So this is an incentive to try a new model. You've been doing it your way for a while. Here's another one. You've got a track record that worked pretty well. But the model would be a subset of faculty would pull away what they normally do, tackle this thing for 5 years, and try that out. And you get this expertise for different areas. What we use the phrase 2 feet in is that this would be the primary thing that they would do. It doesn't mean they couldn't have some students doing what they did before, but they wake up in the morning thinking about this problem. That's what you need to pull this off. So we're trying to fund this model that's, high impact, focuses, has multiple disciplines, has a mission statement, has a goal. I think it was Chris here suggested, it's kind of like we're doing a startup in a university, but it's a research startup. I think that was a way to think of it. So you don't have to dismantle the other systems, but here's one that we get to use Andy's good fortune to get more people to try. That's what we're doing.
If I can follow up too on that, what about?
You don't have to apply,
Oh no! I think it's very interesting. I'm just trying to understand the.
That's
like if
good
you
luck.
operationalize it, what happens? I think these are really interesting questions. You also mentioned that things are more effective when they are single institution.
Yeah.
Is that a constraint for the sorts of programs you're looking for, or?
I don't think we're going to put constraints on it, but we're sharing our bias, right? I tried, what's nice about the faculty member, you can try things. So one of the things I tried as one of the projects is, well, look, Stanford's a great institution, we're a great institution, let's try a project that's cross-institution to leverage into strengths. And it was just really, and they're, 30 miles apart. It was just really hard, that distance. And if you read the literature, it's people in different buildings don't interact as much. So it's just.
Which I understand you all are feeling the pain of right now.
Yeah. Even in your two buildings, you're seeing that? Yeah. So there's a lot of information that suggests the incredible value of the closer you are, the more productive and interactive you are. So we're not going to say you can't do that, but that's going to be the bias of the people doing the evaluation going in.
Yeah, there would need to be a core group of, well, not need to, but we would likely strongly favor applications where a core group of faculty, the PI and co-PIs, would be co-located in a single institution.
And we're trying this, this is an experiment, right? We're going to see how this works. So probably we're going to be pretty conservative the first time and get as close, and keeping in mind, most research doesn't work, right? So we're going to try and probably focus on the ones, we'll keep it to North America to get started. It's going to be at a university as opposed to a nonprofit lab to get this all started. And then if it works right, and we can do the fundraising, we could do every year we could offer new moons to shoot for. And then if that all works, then we could start expanding beyond that. But it's a high risk new thing to try.
At Berkeley, we've seen faculty join a lab and then either fork and do their own separate lab as a subsequent one. So we've seen, or just go back to not having a collaborative, multi-year distinct, Berkeley-style lab or big lab. So we've seen the pattern of let's say Joe Hellerstein, I know joined AMP and then didn't continue in. No, he joined RISE but didn't join SKY. So the Berkeley now has some experience with faculty joining and spinning out. I think Aditya Paraswaram joined and then spun out EPIC, his own separate lab. So the goal is faculty find a group that they feel excited to partner with on a moonshot vision, rather than, let's say, just be the systems area or the NLP area or. And we're seeing at Berkeley, with Bayer does it a different way, quite different, but we're seeing that, as Dave pointed out with the co-located space thing, that there's room to innovate too, and we're open to discussing how multiple labs could share a larger physical space as long as there's still lab meetings and availability of meeting rooms for students and faculty to collaborate in a very kind of intensive co-located way, which is sort of the core hypothesis.
Can you talk about how you choose your moons? I feel like they feel a little fluffy.
What do you mean fluffy?
Fluffy moons,
These are planets.
Okay, these are planets. Okay, so you're going for moons. These are planets. How do you choose? Okay, so
you pick the moon. We give you a planet that you need to orbit around.
So if you want to fix civic discourse, I feel like you need to have a.
Yeah. So let me.
You have 6 months to figure that out. That's the seed grant is you're going to spend 6 months.
But part of this process is we talked to a lot of people and read a lot of papers. So there's several positive examples of research that has been working to help heal civic discourse. So there, and you can think about the social networking as far as you can tell, there's these two extreme positions that everybody thinks one of these two ways. So they try and use more visual things like a 2D map, and your opinion, your topic is over here, and their opinion, so you could, and this has been used in both in Tokyo and in Taiwan to have nationwide conversations about very difficult topics to make progress on. So I think for most of these moons or planets, there's research we can point to that has reasons to think that you might be able to address these things, as opposed to it's just pie in the sky that magic AI will do in some way that we can't figure out. There's research behind, I think, all of these topics. And partly what we're doing is we don't have to use AI. It's just we think AI has been enough progress that we can make these pretty ambitious moons to shoot for, and plausibly people will get there. And how we picked them was a mixture of the biases of the people involved, the people we talked to in the research, that we'd have a distribution of things to look for. But we think if we hit them, it'll have this positive societal benefit.
And some of that research, particularly in civic discourse, is happening here at UW. And Tim Althoff's group is a great person to talk to if you want more specifics on, we cite their work. So, and I think some of the healthcare stuff also. I don't know if we cited UW work, but the paper has a lot more details if you want to dive into, get less fluffy.
That was a big question, so I'm going to call it here, but we have two exciting things. One, these two guys are going to hang out for half an hour up here, so come chat with them. The other thing is the Undergraduate Research Symposium is going on in the Allen Atrium. Lots of good stuff going on over there, and so if you have a little bit of time, Ed's looking at me concerned, did I say the wrong thing? I thought it was upstairs. Is it in Zillow? It's in both? Whoa, okay, we're both right. So go check out the fantabulous undergrad research going on here, and engage with them on their work. But otherwise, thank the speakers so much.